So here we are, final video, final series, set of the series for this kind of benchmark one. We got Algebra 1, or Algebra 2, pardon me, Algebra 2 review, chapters 1 through 3, part 7. That's awesome. Use substitution to solve the system. Okay, substitution. This is way easier than you think, as long as you know what you're looking for. I see right here that y is by itself, and it's this x plus 4. I also see that up top I have a y. So what I'm going to do is that y has a twin, and the twin is x plus 4. So I'm going to rewrite this y with its twin. We're going to substitute it out. 2x plus, well, its twin is x plus 4 equals negative 5. So that's kind of the setup. Let's take it a little bit further. In fact, you know what? Let's rewrite that but a little bit higher so we got some more space to work it out. So we'd have 2x plus x plus 4 equals negative 5. So if I start combining these things, that gives me 3x plus 4 equals negative 5. Okay, I guess I could subtract 4. That would give me 3x equals negative 9. If I were to divide by 3, I got x equals negative 3. There you go. X equals negative 3. Cool, 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 cool. So if x equals negative 3, and I know that y equals x plus 4, I could plug in that negative 3 for the x right here. So that's negative 3 plus 4. All right, what would that give me? That would say y equals 1. Now, if it says solve the system, they're looking for an ordered pair, an xy coordinate. Let's see what that would give me. 1 for my y and negative 3 for my x. And that's it. That's all. Okay, let's look at the next one. It says classify the system and determine the number of solutions. All right, this is another one of those things where we might have duplicates of something. Let's see what happens. Well, if I multiply this top by negative 3, I want to see what I would get. Why am I doing negative 3? Because negative 3 is going to change these 6's into 18's. So that would give me negative 18y, positive, oh, pardon me. Oh, whoa, that's different. Check that out. I didn't even see that. Look at this y goes with that y, and this x goes with this x. Things weren't even lined up, so we got to double check this. Let's do this. Let's divide the bottom one by 3. So I'm going to do 1/3 to each of these. Let's see what we'd get. So the first one we got 6x minus 6y equals 13. Now this bottom one, it says 18 over 3y. I'm going to say that that is 6y, and I'm going to put that underneath the y as positive. The other one is negative, and this 18 over 3 is 6, and that's an x, so it's negative 6x. And then the last one says 39 divided by 3. That's actually negative, so that's going to be a negative 13. Now here's where this is just awesome. If I were to look at each of these columns, something crazy happens, because I would get a 0 here, I would get a 0 here, and I would get a 0 here. And I wind up coming up with 0 equals 0. And you're like, what? That just blew my mind. And what you have to kind of trigger on right now is to keep in mind that this is always true. Like I was mentioning in a previous video, it's not just true, it's always true. And if it's always true, it is always intersecting. And how do you have something that's always intersecting, that's always touching? Well, that really means that it's kind of an overlap. So we have two equations that are overlapping. It's pretty much the same equation. That's what we're looking for there. All right, let's look at number 33. We got 31, 32. Now we're looking at 33. It says graph the system. Okay, a couple of things about graphing this. Sometimes fractions are easier than decimals, especially with graphing. Like in this one. It says negative 0.5x. That's really the same as y is greater than or equal to negative 1/2 x minus 6. That would be so much easier to graph. So that's what I'm going to use. I'm going to cross this one out. Now for the other one, I got a whole lot of stuff going on, but I'm going to do a little switcheroo here. I'm going to add y to both sides, and I'm going to add 2 to both sides. And that would give me, I'm going to rewrite it over here. I would have 3x plus 2 is less than y. You might be thinking, okay, I'm used to y on the other side. Well, then swap it around, but y is still the bigger side. So y now is bigger than 3x plus 2. And then the other graph we had was y is greater than or equal to negative 1/2 x minus 6. So now I got to graph that. Okay, so here's my little sketch of this graph that's going to happen. We're going to have a couple lines. One of them goes down to negative 6, and it has a slope of negative 1/2, which really means it's kind of like this a little bit. It's a line that kind of looks like that. And it's greater than or equal. Because that's equal, that's going to be a solid line going through there. Now the other line says y is greater than 3x plus 2. So I'm going to go to plus 2, and this has a positive slope of 3. So let's say I go up 1, 2, 3, and over 1. So I'm really looking at a line that kind of looks like this. Now notice that I did this one a little bit different. This one was a dotted boundary because it is not equal. All right, so now we got kind of 4 regions, A, B, C, or D. I see that y is greater than in both cases, so I should be above both lines. That means I think that I'm in A, but I want to confirm it, so I need to pick a point out here somewhere. So I'm going to pick a point that I'm pretty sure is out there, and I'm going to do negative 5, 0. I'm going to pick that point right there. Let's see what that gets me. Well, if I got to test them, so that's negative 5 for x. So 3 times negative 5 plus 2 is less than 0. Well, that's negative 15 plus 2 less than 0. That's true, because negative 15 plus 2 is negative 13. And that is true. All right, let's check the other one. If we were to plug in 0 for the x, that would be, or not 0 for the x, 0 for the y. 0 is greater than or equal to negative 1/2 times negative 5, and then minus 6. Okay, so this is a little bit weird. What's negative 1/2 times 5? Negative, that's going to be positive. 5 halves are positive 2.5. Then we got minus 6, and that's going to be a negative number. So then it's really saying 0 is greater than negative 3.5. That is also true. So we got true, 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 true. That means A is true, true, double true. And there's our answer. Okay, now the granddaddy, the big one, the 3-variable system. Okay, I'm going to do a whole bunch of changing around here. And a lot of it I'm going to base on some consistency that I see in the numbers. First thing that kind of jumps out to me is I look at this z column. The z column is all multiples of 3. So I'm going to do a couple of changes. First, I'm going to change them all so that they have the same number. That means if I multiply this middle one by 2, and I multiply the top one by 4, then I would get 12, 12, and 12. Let's see what I would do that. So I'm going to rewrite the top one first. 4 times 3x is 12x. 4 times 3y is 12y. And 4 times 3z is 12z. And then 4 times negative 6 is negative 24. Now for the middle one, let's put that one down here. I'm going to have 2 times 7x, which is 14x. 2 times 7y, which is 14y. 2 times negative 6z, which is negative 12z. And then 2 times negative 1, which is negative 2. All right, so I'm going to label these now as A, B, and C. And I want to make some combinations such that I can start canceling some things out. A couple of things, this should be a little cleaner right there. Let's clean that up a little bit because this is 14y minus 12z. There we go. That looks better. So it looks like this negative 12z is going to help me cancel out the other 12z's. So let's combine with c then. Let's do b and c combined. 12x and 14x from b and c make 26x. 12y and 14y make 26y. And then the z's cancel each other out, combine the negative 24 and the negative 2, and that gives me negative 22. No, negative 26, pardon me. Then for the other one, if I were to combine a and c, let's see what would happen there. A and c, 4x and 14x, that makes 18x. And then I have 5y and 14y, and that's going to give me 19y. And then in the end, negative 14 and negative 2 put together give me negative 16. Now at this point, you're probably thinking, my goodness, this teacher is crazy. I don't know how he expects me to solve these things. Well, a couple things I see. Look at this, 26, 26, 26. So really, I could make that any number as long as those three numbers were the same, because I could divide by 26, get 1, and then multiply by whatever I want. So I'm going to multiply by something that'll help me out with these others. So if I multiply by, let's say, 18 after I divided by that 26, so this is really negative 1, but now I'm going to multiply by 18, I would get 18x plus 18y equals negative 18. Now so this is like negative BC divided by 26 and then times 18. So we got a lot of stuff going on there. Don't want to confuse you with that. Let's see what would happen. We can't just add 18 and 18, so let's multiply each of these by a negative 1. So we got negative 18x, negative 18y, and positive 18. That would give me 0x. 19y minus 18y is just y. Ooh, this looks good now. Y equals negative 16 plus 18, which is 2. There we go. We got something. Y equals 2. All right, so I can work this out from here. Let's see what I'll get next. If I have 18x plus 19y equals negative 16, that's like saying 18 times 2 plus 19 times something equals negative 16. So that's 36 plus 19. Oh, wait, whoa. 18x, but the y is 2. There we go. So 19 times 2. 19 times 2 would be 38. So we got 18x plus 38 equals negative 16. Let's go ahead and subtract 38 from both sides. And that would give me, let's see, 54. Negative 54 equals 18x. And what do you know? 18 does go in evenly into 54. So 18 over 18 is 1. That means x equals negative 3. Oh, this is a long one. Let's go back to this very beginning. The very beginning, because now we got an x, a y, and we just need the z, and then we can make it equal to negative 6. So if I know 3x plus 3y plus 3z equals negative 6, well, if I plug in x, that's going to be 3 times negative 3. Plug in y, that's going to be 3 times 2. Then plus 3z equals negative 6. Okay, 3 times negative 3 is negative 9. 3 times 2 is 6. Plus 3z equals negative 6. So I got to start combining, moving stuff around. We got negative 9 and 6. That's going to be negative 3 plus 3z equals negative 6. If I add 3, we're going to have 3z equals negative 3. Hey, what do you know? What do you know? Z equals negative 1. So there's our answers. Negative 3 to negative 1. Cool, 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 cool. That was awesome. All right, so that's basically how you did that one. Remember, I'm going to be looking at other videos and trying to give you guys a whole list of videos and such to check out. All right, that's it, and have a good night.